So the question tells us that a continuous random variable y has a distribution normal with mean mu and variance sigma square. So first we'll write that down, where y follows normal distribution with mean mu and sigma square as variance. It is known that the probability where y is less than 2a equals to 0.95, and the probability where y less than a equals to 0.25. The question asks us to express mu in the form of Ka, where K is a constant to be determined. So whenever we have normal distributions where the mean or variance are unknowns, we will always have to use standardization to solve the question. In this case, both our mean and variance are unknown, so we will have to use standardization. So we will first standardize y into our standard normal z. So this will be 2a minus mu dividing by sigma. Alright, this will equal to 0.95. So up to this point, we can use our inverse normal from our GC. Alright, we can go to distribution, inverse normal. Our area is 0.95, and since it's standard normal, the mu will be 0, sigma will be 1, and we can find that then z must be less than 1.64485. Alright, so we'll transfer that. So from here we know that this value must be equal to 1.64485. As for the other criteria, we will also standardize it, and we'll have a minus mu over sigma equals to 0.25. This point, we can also use our inverse normal with our GC, and we will obtain that a minus mu over sigma will equals to negative 0.67449. Okay, now we have two equations which but has three unknowns. Since we are looking for mu in the form of Ka, alright, we will want to express these two equations only in terms of a and mu. We wouldn't want the sigma, so we will try to make sigma our subject. If sigma became our subject here, we will have 2a minus mu over 1.64485. Alright, a gentle reminder that it's always good to store up this value in our GC so that we can avoid any inaccuracy. We will do the same on this side, this equation where we make sigma our subject. So we have a minus mu over negative 0.67449. Okay, so now we have sigma equals something here and sigma equals something, so we can easily equate them. So we will end up with 2a minus mu over 1.64485 will equal to a minus mu 0.67449. So visually, we now see an equation with only a and mu variables. So there is definitely a way to express mu in the form of Ka, where K is a constant. So now what we have to do is just simplify this. What we can do first is cross multiply. We'll end up with negative 1.34898a minus plus 0.67449 mu, which will then equal to 1.64485a minus 1.64485a. Note that don't round off all these numbers to 3SF first, because this is not your final answer. So if rounding off your values too early, will end up with great inaccuracies. So next step, we will want to simplify all our mu and a terms. So we'll end up with 2.319344 mu equals to 2.993839a. Then we will make mu our subject, since that's what the question is looking for, and we will have our answer of mu equals 1.29a. So since they are asking for k to be determined, we will write an extra line where k equals 1.29.